Hello Year 5, it is the last lesson I'll be doing with you for a while, maths wise. It's fractions, it's the 18th of January, and today we are adding fractions with different denominators. So last week we were looking at fractions, adding and subtracting fractions with the same denominator. This week we're looking at fractions with different denominators and how we can add those together. Keywords from last week, when we were arranging fractions in ascending going up, descending going down. We had equivalent fractions, we're going to use that again today. Another thing we need to look at when we're doing this week is common multiples. So which multiples do numbers have in common? And that's going to help us when we come to adding fractions with different denominators. For example, 3 and 4, a common multiple of 3 and 4 is 12. 3 times 4 is 12. 24 is another common multiple. 36 is another common multiple. Numbers that are in both times tables. Now, if you remember from last week, this was something that we discussed, a common misconception, something that is incorrect. We have to avoid at all costs. We do not add the denominators. We do not, when we've got this 1 quarter and 2 quarters, the answer is 3 quarters, not 3/8. Remember, we proved that last week. So if you're not sure on that one, look back at some of the previous lesson videos. So here's a recap then of some of the questions that we looked at the other day. We know that 1/3 add 1/3 is 2/3. We know that 2/5 add 1/5 is 3/5. We know that 5/10 add 3/10 is 8/10. Can't argue with those. What if though we have a question like this? 1 quarter add 3/8. These fractions have different denominators, so we can't just say it's 4/8 or it's 4 quarters because the denominators are different. This is where we need to use our knowledge of equivalent fractions. Now, I know that a quarter can be replaced by 2/8. We can prove that because 1 quarter equals 2/8. We've just shown that there. There are the 2/8 on top of the 1 quarter. All right. What I've done is made the denominators equal. Okay, so now we can cross out that and we say we've actually got 2/8 add 3/8, which is of course 5/8. Another example. 1/3 add a 1/6. Now again, the denominators are different. So what can I do? Well, I need an equivalent fraction so that this denominator is the same as this denominator. Now I know again that 1/3 is equivalent to 2/6. I can prove that here. 1/3. So I've done the same to the top and the bottom. And again, we can see from the cutouts there that they are equivalent. So 1/3 add 2/6 is actually the same as saying 2/6 add 1/6, which is 3/6. Now those examples are reasonably straightforward because we only have to change one of the fractions. What if we were to do a question like this though? 1/3 add 1 quarter. We can't just change the third to make it into a quarter because 4 is not a multiple of 3. Now if you remember on the board there, talked about common multiples. What do they have in common? Well, 3 and 4 have 12 as a common multiple. So what I can do actually is with both fractions change them into 12ths. So I'm going to change thirds into 12ths. Well, I know I want 12ths, and I can set this up in the same way that I would with any other equivalent fraction. How do I get from 3 to 12? I have to multiply by 4. Whatever I do to the top, I must do to the bottom. So I'm going to multiply that by 4, which gets me 4/12. Now I'm going to do the same with the quarter. So I've done the third, I know that that is now 4/12. What about the quarter? Let's make that into 12ths. Right, what do I need to multiply the 4 by to make 12? That will be 3. Must do the same to the top. So that is 3/12. So the quarter is equivalent to 3/12. I'm now in a position to solve the question because I've now got two fractions with the same denominator. I've got 4/12 add 3/12, which is 7/12. Let's try one more example. I've got 2/5 and I'm going to add 3/7. Slightly more difficult example here. Now again, 5 is not a factor of 7. 7 is not a multiple of 5, so I cannot just change one of these fractions. I need to change both of them. I need what is called a common denominator, a denominator that is a common multiple. What are the multiples of 5 and 7? Well, sometimes the easiest way to do this is to multiply the numbers together, and 5 times 7 equals 35. So I want two fractions that have a denominator of 35. So for 2/5, I'm going to have to multiply by 7 and with 2 as well. 2 times 7 is 14. With the 3/7, that's multiplied by 5, so I must do the same to the top. 3 times 5 is 15. So what I have now is 14/35 here. Instead of 3/7, I can use 15/35. And the total for those, 14 add 15, is 29/35. The tasks then. These are the pages in the textbook which are uploaded to the assignment on Teams and on the website. So you can look through those again, right, if there's anything you're not sure of. And then there are two different tasks today. There is this sheet here, and in fractions, this is for Mrs. Richardson's group. So make sure you open the correct document. They are titled with Mrs. Richardson's group and the main tasks, and then this is the main sheet, and you can see the main objective there is to add fractions with different denominators. Make sure you have a go at the challenges as well. There are challenges on both sheets. Make sure you have a go at them. We'll be going through the answers, or somebody will, later in the week. Bye for now.